Hello, Algebrites. On this wonderful day, we are going to determine if a relation is a function, and most of you will be like, what's a relation and what's a function? Well, don't worry, we will get to that. By way of introduction, let's take a gander here. The desks in a study hall are arranged in rows like the horizontal ones pictured. What is a reasonable number of rows for the study hall? What is a reasonable number of desks? So pause, take some time to answer that. What number of rows would be impossible? What number of desks would be impossible? Don't forget to explain. And then over here, let's complete the tables at the right. So go ahead and pause, consider that, and then come back for some suggestions. Are back. So let's see here. What's a reasonable number of rows? Well, if you just think about a normal size classroom, of course your normal might be different, but we can also find out what would be abnormal, right? So if you said maybe two rows maybe, but maybe up to 6 rows, 7 rows, right? 6 or 7 rows. Okay, which means if we had the desks, that would mean there'd have to be 10 desks here, because each row has 5, all the way up to 35 desks, okay? Now, of course, you could have some desks that have, or some classrooms that are bigger, but we'll call this right now reasonable here. Okay, what number of rows would be impossible? So, for example, 0 rows would not be possible. What about 2.25 rows? Okay, why? Because we're not going to do fractions of rows. It says that each row here has exactly 5, so we're not going to do decimals. We can't have negatives. Can't have negatives. What else? 100 rows. That's too much, right? And so, therefore, what also would be impossible for the desks? Well, we can't have 2.5 desks. We can't have 200 desks either. Can't have negative desks. So those are considered. But we also can't have even some whole numbers. For example, 4. We can't have 4 desks. Why? Because that doesn't follow the rule. The rule needs to have 5 per row. All right, and completing the table on the right, we would have 5 seats, 10 seats, 20 seats, and 35 seats. And of course, these here sound very reasonable over here. We're not going to get 0 and into the negatives. We're probably not going to have 8, 9, 10, 20 rows down here. So, all right, that brings us to the idea of domain and range of relations. So first off, what is a relation? A relation is any set of points. That's it, a set of points. 1, 2, that's a relation. Or all of these combined is a single relation. The domain is simply the input of the relation. In other words, the stuff that's over here in the x. And the range, well, there you go. I'm sure you thought about that. That the range is simply the output, the stuff that comes out of my relation. A relation can be represented in 4 different ways. A set of points, which we'll see down here, a table of values, which this is here, a mapping diagram here, and finally we can graphically represent it. So, example number 1. What is the domain and the range of the relation below? Well, there are 3 things to consider when we are doing domain and range. Number 1, we're going to put these guys in order, from least to greatest, ascending order. Second, no repeats. If there is a number that shows up more than once, then we don't need to write it. And thirdly, we need to use these brackets, because these brackets mean that we are talking about a set, a group that belong together. All right, so what's the domain? Well, let's see here. The lowest number here is -1. Then we have a 6, and notice that the 6 repeats, so I don't need to write it again, and finally we have a 9, and so we end bracket. There's my domain, -1, 6, and 9. So let's repeat that process here, but with my y values, my range. So -7, -5, -2, and 3. Again, I'm going in ascending order there. There weren't any repeats, so I didn't have to worry about that here. All right, so now how to represent relations? Well, here's one representation. Table of values. Well, we can also represent them with a set of points. And in doing so, we also are going to use the bracket because it's a set. And we're going to represent each one of these as a point. So 6, positive 3, then another comma, 9, negative 7, comma, 6, negative 2, and don't forget your parentheses around each point, negative 1 and negative 5. And I'm going to put an end bracket on that. If there were more room, you would just see all of this on a single line. All right, and these don't have to be in any specific order at all. So you could have switched these things around as long as 6 and 3 are together, 9 and negative 7 are together. Okay, a mapping diagram does follow a little bit of different rules. Your domain, you're going to write over here and keep the order like we did. So negative 1, a 6, and a 9. But then our range, we're going to write over here. And also we're going to keep the same order there. So negative 7, negative 5, negative 2, and negative 3. Now here's what a mapping diagram does. A mapping diagram tells you where the negative 1 goes. So we know from the point here that negative 1 goes to a negative 5. So I'm going to draw an arrow that takes me there. Now where does the 6 go? Well, it turns out that the 6 goes to a 3, and clearly I messed up. Oh, that's a positive 3 there. A 3, but 6 also goes, notice there, to a negative 2. So I'm going to have two different arrows coming out of the 6. And lastly, the 9 goes to a negative 7, like so. So there's my mapping diagram. It's a visual representation of how the domain behaves going to the range. And lastly, we're going to write this as a graph. The nice thing about this is we know the domain and range because we already wrote them down, which means when I'm working on my crosshairs here, I know the lowest I have to go is negative 1 because of that right there. And then the highest I have to go here is a 9. So I need to give myself some room there. So I don't need lots over here. I don't need lots over here. And repeating that, I need to go all the way down to a negative 7 here and all the way up to a 3 here. So as I count things off, I'm just going to pay attention to those domain and range restrictions. So here I set this up. My window, notice I didn't put my origin directly in the center like we are tempted to, like I did up here. This was just a sketch. So here, everything will fit inside of this window. Now all I have to do is map things out. So I have a 6 and a negative 2, so here's one of them. I also have a 6 and a 3, which is over here. I have a 9 and a negative 7, which lives far in this corner, and I have a negative 1 and a 3, which lives in that corner. And there we go. Here's my representation. So what do you notice about one of the elements in the domain? Well, notice we do have a repeat here, and not only does it repeat, but the 6 goes to two separate elements. The 6 goes to two separate elements in range. Now we're on the next page, and it's your turn. Go ahead and attack, kill, destroy. Pause this and check for your answers. And here you go. Domain range, set of points, mapping diagram, and your graph. Pause if you need more. So what do you notice about an element in the range? Well, in this case, we don't have, in the range, we do have a repeat. Notice we've got the 3 that shows up twice, which is here. So the 3 is mapped to by two elements in the domain. And there we go. All right. So that is Introduction to Relation. You can watch the next video to introduce talking about functions.